Speaker today is data scientist and machine learning specialist Dr. Charles Martin. Today he's going to talk about modern applied artificial intelligence. He's a specialist in applying mathematical models and software engineering to complex big data, analytics and AI problems. He has worked for a number of industries and companies on Wall Street, for companies such as BlackRock, also for technology such as eBay, has consulted a lot and was involved in the biggest IPO since Google, which was called Demand Media back then. He started college with the age of 15. He went to Ohio State University. He's from Ohio, as you can see. Because we are good friends, so because they had a supercomputer back then. Still a teenager, he won a National Applied Math contest. His research involved non-equilibrium statistical mechanics. He received his undergraduate degree from Ohio State University and a PhD from the University of Chicago in, in theoretical chemistry from the University of Chicago. If you want me to repeat all that, I can do that. He was the National Science Foundation Fellow. His postdoc, with his postdoc, he went to the University of Urbana-Champaign in Illinois because they had to their National Center for Supercomputing and Applications. It was the same time, the same office when Mike Andreessen was at the same school coming up with Netscape. Charles worked helping studying the foundation of perception and learning, ranging from the initial quantum mechanical events in vision to building hybrid biological silicon neuromorphic devices. He's a veteran in the field in machine learning, artificial intelligence, but also an expert on other fields, he's working with Berkeley right now in a theoretical approach to why deep learning actually can work. He's also working with our former speaker, Carl Page, which is a highly controversial physics project. Charles and I, we go back a long time, University of Chicago, and back then he was not only the brightest and the smartest, he was also by far the fastest. I think he finished his degree in half the time that was required to do so. So we're very happy to have him here today.
Okay, thank you for the introduction. So today I want to talk about AI. A lot of people don't know what AI is. I think you remember seeing the Terminator. Yeah. And in the Terminator, this is back in the 80s, he said, my CPU is neural net processor. I try to talk like Volcker. A learning computer. And you may recall, if you give the AI to Arnold and he tried to take over the world. And this is a lot of the fear. A lot of people have a fear right now that AI is going to be this disruptive. And so what I'd like to do is kind of talk about what AI is and where the challenges are, where the potential is. So the first question is, what is AI? And there's a lot of controversy about this. I've been working in the field since, really the early 90s. And there are, AI right now, you may recall there were things like expert systems. And people would build expert systems. They would try to do things like build expert systems for doctors. And back at that time, this was what people thought AI was. And then recently we hear a lot about machine learning. And machine learning are basically sort of like statistical algorithms. It's like running statistics, but instead of having 100 or 200 variables, I can have 1 million variables in my statistics. AI today, when we talk about AI, we're talking about deep learning. We're talking about these multi-layered models that learn representations of data, and they try to mimic the way the brain works. And the advances right now in our neural networks are things that we were working on probably starting in the 80s, the 70s. Volker asked me to talk a little bit about some of the work we did at Chicago. There's a very famous theoretical physicist and chemist that was like back then, this in the 60s, the same thing, named Christopher Longet-Higgins. And he was at our group at the University of Chicago, and he left and went to Edinburgh and started an entire field of research called machine learning and perception. And he has a couple of very famous students. One of his very famous students is Geoff Hinton, who now is at Google, is considered sort of the grandfather of deep learning today. And he worked on systems like in the early 90s called restricted Boltzmann machines, and about 10 years ago started bringing the field back with something called deep belief nets. And they entered these contests. There's a contest system called Kaggle. And people can enter machine learning contests to see whose algorithms work the best. And all of a sudden, these deep learning algorithms started working better than anything available. And one of his postdocs is Yan-Li Kun. And Yan-Li Kun invented something called a convolutional neural network. And he's now running the AI group at Facebook. And convolutional neural networks are these things that are used for when you write a check and you insert it into Wells Fargo and it can read who you are. That's a convolutional net. And so these things have been around for a very, very long time. And again, it was about 10 years ago where all of a sudden they started coming back. And what you have to, and for a long time, AI was sort of, it's gone through these phases where it's been very popular, and then it sort of dies. Then in the 80s and the 90s, it got very popular again, and we were all working on it, and then it died, and now it's come back. So what's going on here? The idea is that you're trying to design a software system that can mimic the way biological neurons work. That we have our neuron, and this is sort of what the little pieces into the neurons in our brain look like, and they send little spikes down this chain. There's a neuron, the nucleus, it sends a spike down the myelin sheath into the axon, and these spikes are what we think are part of how our brain learns information. So a bunch of computer scientists and some theoretical physicists got together and built models of these neurons. So for example, I got interested in this back, I was in my group at the University of Chicago. My advisor, Carl Fried, had this book laying around, the Statistical Mechanics, New Problems, New Applications, 1972. So for me, that was new, even though I was a grad student in the 90s. And I started reading, and there was something called the Wilson-Cohen model, which is the stochastic model of spiking neurons. And this model was invented at the University of Chicago to try to have a theoretical physics model of how the brain works. And actually, Cohen has done a lot of interesting work. For example, he has mathematical models of epilepsy. What causes epilepsy in the brain? They've developed all sorts of models for describing the dynamics of neurons. And then later, there was a physicist, this chemist, Hopfield, who used something in physics called the Ising model. And they started making static models of neurons. And these static models are based on things in physics called spin glasses. And they were able to make memories. So you could have a software system, you could give it a bunch of characters, 1 and 2 or 3, and you could show it another character and it would remember, you could show it something like a partial image of a 3 and it would remember it's a 3. And these days, there was also a very famous German, Kohonen, I have to mention that for Volcker, who invented something called self-organizing maps. And we were studying this at the University of Illinois. This book, Models of Neural Networks, was written by my postdoctoral advisor, Klaus Schulten. And I don't know, it was like the 10-volume series on the statistical physics of neural networks. And this stuff was very, very popular in the 90s. And then at some point, it just sort of, all the research died out. No, wrong way. So today, all of a sudden, it's come back. And it's pretty amazing what people want to do. For example, I think we all heard about these self-driving cars. We all sort of expect in about 10 years, no one's going to own a car anymore. The thing will just drive you around. I mean, Tesla is sort of doing it now. Google is, this is really a brainchild of Sergey Brin, one of his things to develop self-driving cars. And Sergey has also said he wants to build a benign version of HAL from the 2001 Space Odyssey. And they're working on it. I mean, they've acquired this company, DeepMind. They acquired a company I worked with many years ago, Aardvark, which was a very early stage machine learning company. And they've just put maybe 5,000 people or more. The entire company has shifted to working on this. And one of the most important advances that's come out of this has been AlphaGo. So AlphaGo is it's sort of like the chess program in China. Very, very sophisticated game. Much more sophisticated than chess. And recently, Google released a product called AlphaGo where they beat the world Go champion. And some people have said in China, this is like their Sputnik moment. That they realize, well, look what this thing can do. I mean, I think after this happened, the South Koreans put a $500 million of money into research for AI. So this is a big deal to be able to, I mean, no one would imagine this is possible. So a lot of people believe that AI is going to be as transformative today as the internet was in the late 90s. So we're just seeing the beginnings of this, and already the beginnings are pretty amazing. So one question is, what can this stuff really do? And here's a great example. One of the big advances in AI have been in object detection, image recognition. And this is one of the harder problems. Is this a puppy or is it a muffin? And this is actually rather hard to do for the machine. It gets confused between this. And there are a number of examples like this. But essentially, the AI has learned how to recognize any image. And it's quite good at it. And the applications, I tried to sit down, what are the applications of AI? Like, what's really going on? And I look across all the industries, I realize there's just a huge number. In the internet, or the space I've worked in for over 10 years, you have obviously advertising, like what Google does or what we were doing at eBay, has been the heart of machine learning. This is where a lot of it incubated. But now we have image classification. The AI Amazon sells a service, you can give it an image, and it will tell you what's in the image. And this is an amazing product. There are companies coming to us. We have a company that's come to us in Japan, and they want to automate all of the production of their cars. So when they're doing inspections on the engines, they just want to get rid of all the people and have the machines do the inspection on the engines. And these are the kinds of things going on right now in industry. Speech recognition. I mean, I think we all use Siri. Siri's amazing. I mean, 10, 15 years ago, Siri would have been unthinkable. I worked with George White, who was one of the top researchers here at Stanford, and he said it was just unusable. The machine, the speech recognition was unusable back then. Even at 95% accuracy, it was unusable. Today, it's phenomenal. Speech translation, the ability to translate. We expect that soon you'll be able to open up Skype and you'll be able to talk to almost anyone in the world, and it will just directly translate the language for you in real time. And that's already happening today at Microsoft. Semantics, some of the work that Volker works in, AI developing semantics, being able to look at a document and understand what it's about and to describe it. Chatbots are very big. A lot of people we see now, you may have discovered that Morgan Stanley is trying to replace your financial advisor with a chatbot. So that's happening, actually. And recommendation systems, things like the Amazon Recommender. But there are all sorts of other applications. In medicine, for example, trying to correct medical errors, detecting cancer, looking at diabetes, drug discovery, personalized medicine. In entertainment, you have now one of the big video game companies just released a product that allows you to build your own player for the video game. And it's completely AI, and it will play the game. It can play these video games, and people buy and sell these characters. So you could actually make an AI and sell it to somebody, and they'll buy this, and they'll buy it from you, and it will play the game for them. I don't play video games, but it's amazing to me. Interactive toys. Toys you give to children. The child will speak to the toy, and they can understand what the child is saying. Yeah, and of course, security is a big concern, especially with facial recognition. We have systems now that can look at every single person in the room, and the computer can recognize every one of you, and we know who you are. If you're on Facebook, and you go on Facebook, and it knows who you are. That's really scary when you think about these face recognition systems or video surveillance systems everywhere that can recognize who you are just out of a crowd. And that's pretty much today's technology. That's not, they just need to have a record of who you are, obviously like your driver's license. That's today. Satellite imaging, obviously for border security, child safety. We had a client come to us, we spoke to them about an idea. They monitor the emails of high school students, of high school and junior high schools. They provide email to the junior high schools and the high schools, and they want to look for people preying on the children. And they're using machine learning now to study the emails and the text messages, and they've been successful in catching some of these guys. And then the other is machines. Not only autonomous cars, but autonomous trucks, autonomous farming, autonomous boats, crash avoidance systems, robotics. I was, a couple of years ago, I was walking around, I went to a friend's house, and in their garage they had a startup, they're building a robot to replace a longshoreman. Or to replace people taking products off of trucks. So these are all in the works right now. So a really good example is in medicine. Google just released this a few weeks ago, that they've developed a system that can actually diagnose diabetic retinopathy. And it's pretty much as good or better than the doctors. Now the doctors actually, the doctors maybe have a recognition of about 65%. So the machine is not perfect, but it's approaching the level of a professional doctor, and that's pretty amazing. Another example is for those who don't like to cook. You have robots in the kitchen. And this is a product now that you can buy, and it's a robot chef, and you can install it, and it will cook all your food for you, which is amazing. Yeah, this exists. But I think even more remarkable, this came out of China recently, is a Chinese robot dentist. I see some frightened looks in the audience. But you know, for those of us who hate going to the dentist, it's going to get worse. But this is real. This is today that they've developed a robot dentist that can fix your teeth. And you think about what that's going to do to all the dentists in the world. But this is real, and this is today. This is right now. This is not 10 years from now. I mean, this is now working. So this is the kind of things that can be done using off-the-shelf technology today. So there's been a lot of concern that this is going to have a huge revolution. In particular, there's a fellow who runs they sort of run a consulting matchmaking service where you bid for projects online. So, he provides IT training. But he sort of said he's concerned that, this article he wrote, that AI may be the death of the Indian IT sector. That we're seeing huge transformation, not only here, but worldwide. That IT is changing drastically, and there have to be changes in the education system and training for companies to survive, because things are just changing rapidly. And we've had several clients come to us from India who said, look, we want to do projects in AI, and we need to work with someone in the U.S. because we don't and that's something which is new. I haven't seen that recently. If you look at the jobs, what's going on? If you go to AngelList, I found there were over 3,000 companies that call themselves AI companies. That's a lot of companies. I remember there were like 5. That's a lot of companies with an average valuation of $4.9 million. You look at Amazon Alexa, they've hired 5,000 employees to work on Alexa and Echo, and they have 1,500 open positions just in AI. Microsoft, 8,000 employees working on AI. And again, the same as at Google, the same as at Facebook. All of these big players are really moving in this. This is at scale. And so we do have this concern. You're going to need a revolution in how you train and educate people. An example would be there was a self-driving car class from Udacity, which is an online learning product. There were 5,000 students in the class. I think the class was $800. And there are 5,000 students worldwide in the class. And I went to San Francisco. I met some of the guys in the class, and it's amazing. They're just sitting around learning how to make self-driving cars. Now this is just the first class. It's a three-quarter class. And this is today. It's pretty amazing but also you have executive level training. And not only do we need people who can understand AI at the engineering level, but at the executive level. You think about all the companies that are out there. There's very few people who are in leadership positions who've ever been exposed to any of this. Or if they have, maybe it was 20 years ago, and you haven't really been actively working in it. So a lot of the large universities are beginning to set up executive level training programs. I've been talking to the group at the University of Berkeley. They want to set up a data science school. It's very, very challenging because there are other schools. There's engineering and there's math, and who's going to run it? And while these guys are arguing about who's going to develop these programs, you have places like Udacity setting up online services, servicing 5,000 students. And one of the concerns I have is, can you really teach math, physics, and engineering online? Can you do it without mentorship? Can you do it without apprenticeships? Which is really, if you think about when you get a PhD and you learn how to do science, it's an apprenticeship. Standard German model for science. You go and you work with someone for a few years and you learn how to do it. And that's not something we really see a lot in industry today. Companies just want to hire people who know how to do things already. But that's not the traditional way of learning how to do this. And for them, it's challenging to provide training. You look at education and jobs, the kind of things AI can provide, having a mentor. Every single learner would have an AI mentor that could help them. The challenges we need to change education. You need to develop 21st century skills. What are the universities are still teaching engineering for things we were doing in the 50s. You have to have interactive data. The ability of AI, these are interactive systems. So you can develop systems that are interactive, can work with you. I don't know if you ever remember when you ever took engineering classes back, you had these little interactive programs you would work with. They would ask you a question, you answer the question, you move on. They're very good. Now, you can imagine that doing it at scale, very sophisticated learning systems where essentially, it's like you're interacting with a professor. And again, we're going to need universal access to global classrooms. And we're seeing this more and more with MIT OpenCourseware, but very much Audacity, Coursera. Many of the way in which you learn AI today is not at the university. You learn it through these online systems. There are few, but there are not many universities really teaching AI, and most people are probably doing it online. And then the point, of course, is that you need to retrain. This is going to keep getting more and more. I mean, we're just seeing the beginning of this. So I don't even know what it's going to look like 10 years from now or 15 years from now. All the technology is going to be different. I have a PhD in this stuff, and every time I turn around, there's something I don't have any idea what's happening. Every 6 months, it's like the entire field is new. So, and then I would say we just have also the concern. I call it the cult of the algorithm. I think we all know that there's a lot of danger in having these algorithms that are running in society, and they're just there. We don't know what they're doing. What are they actually doing? What are these algorithms doing? And we don't have any real perception of how they're affecting us. So I got to leave with this idea, this quote from Vladimir Putin. Artificial intelligence is the future, not only for Russia, but for all of humankind. It comes with colossal opportunities, but also threats that are difficult to predict. And whoever becomes the leader in this sphere will become the leader of the world. So I'll open it up for questions if you have questions.
I heard there's a movement to endow sort of human rights to the robots or AI. It already started in the EU, basically like 3 years ago, to talk about that. How would you
Should we have human rights for AI? Well, that's, I guess people start thinking about it. What we're seeing now in terms of AI, I don't think it's going to look like a human in the way in which we think about it. If you think about how we learned to fly, for years we tried to mimic birds. And it didn't work. A guy would put a wingsuit and jump off a mountain and fall on the ground, hit the ground. The story of Icarus. And then we realized what we really need is drag and lift, and we started designing airplanes. And now we have supersonic jets and spacecraft. And the flight, how flight works is very, very different than how nature flies. And I think a lot of AI is going to be like that. AI is going to augment human intelligence in ways which are going to be much more transformative. You have a system that if you give it an image of a dog, it can recognize what that dog breed is out of all the dog breeds in the world. There's no human that can do that. Maybe there's 1 or 2 humans who could look at a dog and know every single breed. Or you show the AI a picture of a plant, and it can recognize the species, the genus. It knows exactly how to categorize the plant. There are very few humans that can do that. So I think that it might be a little premature, and I think the real concern is that some of these tools will augment human capacity and will be so much better that humans will have nothing to do. But there definitely is a concern. I mean, whenever these things get so powerful, people are concerned that it might become intelligent. So it's maybe premature, but I think it's going to be much more disruptive than what we can imagine.
He's a dentist.
Oh, he's a dentist. In the back.
You posited a question at the beginning: should we be worried?
Well, how do you feel?
My first name is Laugh, which is the reverse of how. My second name is Luddo. And I have seen what technology has done in the last year to change the democratic political system in the world. That worries me. When I see that quote, I am very worried. And tell me, should I not be worried about getting rid of all the jobs that may be meaningless, maybe the manual, getting rid of all those? I am going to win President of the World as laughed Luddite.
No, I think there's a real concern. I mean, if you ask, if we develop self-driving cars or self-driving trucks, what is 40% of the things that my brother's a truck driver? He owns a truck, runs a flatbed truck, has a business, does construction work. The trucks will be completely automated. Does that mean the truckers are going to go out of business? All these guys who do long-haul trucking across the country? There's a concern, and that's a huge amount of people in the country who drive these trucks. What are they going to do? If they get reduced by 90%, I think it's a real concern, and it's going to be as transformative as it used to be. People used to work in farms, and farming pretty much has disappeared and become completely automated. And I think that there's a concern about that. And I think even in more high-skilled labor. I mean, look, I go to clients, and we went to a client once, we were going through a pitch, and one of the fellows says, look, I just want to know how many people can I fire if I buy this technology. I go, oh, that's brutal. But it's the reality, and it's a deep concern. And and I think that the challenge is we have to stay out in front and figure out, to make sure we do the right thing. If other people get in touch with this technology, they're not going to be concerned about anybody but themselves. So that's kind of why we're here talking about it. I think people, we're going to have, there's some people have a more utopian vision that everything will be automated and we can just give people free money and they'll just do art and sports and things like that. And I'm somewhat skeptical about that.
So, what do you think about the restrictions that have been placed on a lot of companies in the Western world versus some of the others, say in China or Russia, where they get access to government data? The rate at which they're able to iterate on an algorithm is so much higher than what we can do here because of privacy concerns. How do we gauge that dilemma in terms of how we stay ahead, but also maintain kind of the ethos of responsible development?
Well, I think that what's happening is internally the companies are innovating. So if you look at Google or Facebook, they have massive amounts of data, and they're able to move very, very quickly because of it. And it is true, it's a concern. About 10 years ago, I worked on a project with France Telecom for the EU, and about halfway through the project, we realized I couldn't work on it anymore because I'm not an EU citizen, so I couldn't access the data. And that restriction pretty much killed the project. What are you going to do? And I think it's the problem with things like big data is that you have a company, they get Hadoop, they put all their data into the system, and it's great. All the data's there and everybody can see it, and then it gets hacked, and now the data is exposed. So I think, and if the kind of things going on, like with Equifax, for example, were going on in China, I don't think that these guys would be getting golden parachutes when they leave the company. So, we have to deal with the security issues around data much more seriously if we're going to be looking at it at scale. And I think that there's a real concern because you can do a lot of things with this data, as you said, either in terms of manipulating politics or like with Amazon. I mean, Amazon has pretty much killed the retail economy. We call it the retail apocalypse. And because they have the ability to target people based on what they want to purchase, and they can just bring the price, and the fact they pay no taxes. So it's a big concern, and I think that we have to come to grips with these privacy issues of the hacking and people breaking into these systems before people are going to be much more willing to share their data. I think it's actually going to get worse with all the hacking going on. That's my take. Any other questions?
In past industrial revolutions, productivity gains and population growth have sort of offset the job losses. People do different things, and there's clearly disruption. I gather from, you never quite stated it, but you think that no longer is going to hold with AI? That the job displacement is going to be greater in at least a period of time, decades perhaps. We're going to lose more jobs than we create for productivity gains and population.
I think with the current political situation, I think a lot of people believe that's happening now. And that's the concern. We've lost a huge amount of our manufacturing base. What's going to happen when we lose the trucking base, or we don't need people working in banks anymore because, or accountants or lawyers.
Or AI.
Well, don't trade it.
So, and again, there's a more optimistic view. Look, this technology, for people who know how to use it, it will augment them and make them so much more powerful. You can do all of these things. But people are going to have to be more creative and more entrepreneurial in order to be successful.